Thank you. Thank you very much. I see a lot of people. I was not expecting this. So, my name is Alan Franzoni. I'm an engineering manager at Ivan. So, maybe you don't know the brand. Just a question. Does anybody here use Kafka? Some people. Okay. Maybe you recognize our brand because we are leading one of the recent open source changes in Kafka, which is called diskless. Otherwise, we are a multi-cloud provider for managed data service and AI. So if you just want to see the open source effort, it's there, and maybe you've heard about us. But this is not a talk about Ivan. Rather, this is a talk about Python. Because at Ivan, we use Python quite a lot, I would say, almost. We almost use Python exclusively for most of our products. But Ivan is now a scale-up. In fact, we just reached the 100 million ARR milestone, which is great. But the company is 10 years old, and the company started as a monorepo full of Python code. 2015, and then the company evolved, as you may know from startup or scale-up life. It's not a kind of, let's say, environment where you stop and you deeply rethink what you have done and what you want to do, because you just want to grow and grow and grow. So the monorepo was originally untyped, and you know, MyPy started in 2012, but actually it was not really usable until 2020, and 1.0 was released in 2023. So a large part of this code was untyped. So some stats. I could get you guess, but I will just tell you, this is the file count for our monorepo. This is the amount of blank lines. This is the amount of comments. And the last one, you guess it, it's the amount of code lines in our monorepo. For context, Ansible is 140,000 lines. Django is 350,000 lines. So this is quite a large monorepo, untyped. So we had a lot of silly and not silly issues with our code. We had extremely long CI runs with all the testing that would fail in the end for very small problems like, you know, calling an integer method on a string or something like that. But we also had something worse, like production incidents caused by completely avoidable issues, something that any kind of type checking would completely prevent from happening. So our developer experience was absolutely abysmal. So we said, hey, but now MyPy is out, we could just leverage this to make our code base better. So let's start with it. Let's annotate and check in CI or during development whatever is happening in our code base. But there was a problem. Without stopping the word. So we would go to our managers, to our VP of engineering and say, hey, you know, we are stopping any kind of development for a couple of months so we can get our code base completely statically checked. We haven't actually tried, okay? It was an idea, but we haven't tried. We couldn't, so we had to do it while we were running. And did it work? Sort of. But you know, what we discovered is that actually doing statical type check is a moving target, okay? So let me explain how. Let's get to basic MyPy functionality. So MyPy usually starts in lenient mode. It means that it will type check parts of the code which are the proper type annotations. If the part of the code is not annotated, then type checking does not happen. There are tons of options that you can configure. The usual setting for such configuration is per file, and MyPy itself changes. So when we started doing this, MyPy was not at 1.0, so it was changing even more. Now it's a bit more stable, so you can rely a bit more on it, but this is the MyPy configuration file. Okay, it's this, and this, and this, and even this, and even this, and even this. Okay? And all of this you can usually configure per file. it's not a global setting. You cannot take a global setting from the get-go, because then the checks would fail on your code base. So you need to have something which works all the time, so you need to do it incrementally. And we said, we can do that incrementally. And we went through multiple stages of grief in order to achieve this incrementally. So I will start with the first phase, denial. Okay? So at the beginning we said, we will do it whatever it takes. Okay? So we created a configuration for MyPy. So what would you do? We would put the best configuration, so the stricter configuration, on top. We would add modules that would be strict enough. Other modules would be on lower configurations. Okay? And as you went on, you just went on adding typing to all files, and then you would push a file, a module, from a lower configuration, let's say, tier, to a higher one. Okay? That was kind of useful, but the reality was that the result was a kind of an horrible mess. Okay? You must remember to manually shift files up. Your default for new type, for new files that you add, cannot be really strict, because otherwise nothing will work, the check will fail. And then you end up with a very, very long configuration file, which at its heyday was 1,500 lines. Okay, very difficult to manage. Then at some point, in order to make it shorter, you start adding some asterisks for matching multiple files, and then you never understand what kind of MyPy configuration is being applied to the file that you are currently checking. This is not completely true right now, because recently MyPy added a way to add those configurations per file, like on the top of the file, but this wasn't true since forever. So we discovered that you do not simply go incrementally, you do not simply type check one file after another and call it a day. That's not what you can do. So we get to the second stage, anger. Okay, we said, let's use a leaderboard. Okay, the winners will take it all. So we had a per team leaderboard. We had an automated tool to check how many files we had and how many files were not strict. And we had this leaderboard with different teams, and we were kind of running and competing against other teams to get typing down. This was kind of useful, okay? But you get diminishing returns as you go on. So at the beginning, there is a lot of value, but then you spend a lot of time adding annotation, but what you discovered is that you don't just add annotations. Sometimes, when you do, you want real type checking, you don't just add annotation, but you need to change some parts of your code which need to be changed after the typing is properly done. And this led to incidents, because sometimes it's startup code, not everything is well tested. We would get production incidents just because we were trying to add typing to our code. So we understood, you have full static typing checking, like statically typed language, is great. If you have partial static type checking, is still good. But if it's unknown, so if it's not easy, by taking a look at the code, to understand whether the code has proper type checking or not, because the configuration is messy, then that's bad. It gives you a false sense of security, where you think that type must be only the type at that point, and when you run the code, it's not like that. So that's something that we discovered on our skin, let's say. And there was another point, less relevant today, but it still happens sometimes. So when you were young, you were programming in a language for the first time, and the compiler would tell you, "Wow, this is not working, this is wrong." Did it ever happen that you said, "Hey, I found a compiler bug," and somebody got to you, maybe a senior programmer, a manager, a mentor? What did they tell you? Anyone? This is a classical phrase. The compiler is always right. which is not strictly true, but it's unlikely that on the first 10 minutes on a new language, which is very used, you can spot a compiler bug. Problem is, what we found is that MyPy can be wrong or buggy. So it can tell you that the type is wrong, but the type is actually right. You double check and it's right, but MyPy cannot yet understand this kind of, the kind of types that we're checking. I think I have opened at least a couple of bugs in MyPy. MyPy is progressing, less likely that you find those right now, but it can still happen that you get a very large wall of text saying, hey, no, I was expecting this type, the type is completely different, and you don't understand why. It can be a problem with MyPy. So we go to the next stage. The next stage is bargaining. Okay. One example, this didn't work for a lot of time, now it's working. So this is a very common pattern that you can see in many languages, like in Java, it's built in on the optional object. Okay, so you have something like a function which takes an optional object, and you have a default value that you want to use when the optional is none. This didn't work for a lot of time in MyPy. It would say, hey, I'm trying to coerce everything to object, but it's not working, so I cannot type check this. And there is another problem. So when you are doing deserialization, typical issue, okay, you load something, you say, hey, but I want a string. You enforce a string, so you annotate a variable, but in the end, the type is not what you expect. So when I was first looking at this code once upon a time, I would expect MyPy to complain that JSON loads has no well-defined type, so since he could not tell me that the output was a string, it would just say, hey, break something, you need to do something, you need to manually do a cast. No, this doesn't happen, okay? And the same is with data class. So this example would actually break at compile time, statical check time, but if you combine, if you do it at runtime, so if you get something assigned to A as an int, as a different type, and you combine it with deserialization, you get unexpected behaviors at runtime. Similar issues occur with type dict, okay? So after doing a bit of bargaining, we realized that we were ready to do something, but there was one more villain in our system, let's say, and that led us to depression. Can you imagine what is the last villain? So let's suppose that you have a fully annotated code, but there is one specific annotation that can drive you mad. What is it? Any. Exactly. At the beginning, we did not think of any as an enemy, you know, because it's just any. It's not like, well, you do some Rust and you do something which is called unsafe, then you may think it's unsafe, but any is just cool. It's not something that sounds like very bad, but any was a problem. So we discovered that we had quite a bit of annotated code that used any as a value, but any allows you to basically skip type checking for whatever is there. But in the end, we got to the last stage, acceptance. And acceptance is where we found something that could work and provide value without driving us mad. So this is a script, it's kind of template script. It's available in the slides, in the slides that you will be able to see and download it. So what did we do? Instead of doing a per file modification, a per file, setting MyPy settings per file, what did we do? We created a script, which is called like MyPy inject type ignores, which works like this. So basically, the script would run MyPy on our whole code base, parse the output, and then it would add a very specific type ignore only on a very specific line. Okay, you can see that this function is missing a return type annotation, and there is a very specific ignore added only on this line. What is the outcome of this? If you add new code, even to existing files, the new code must be strictly typed because the default is to use a very strict typing. You can clean up only the parts of the code where you want to add types, and you don't risk of breaking something else. So you basically get a system where you cannot add untyped code by accident, because with per file ignores, it could happen that you created new code in a file which was not typed, and you would by accident create new untyped code. So you were chasing a moving target. You were adding new untyped functions as you were trying to remove typing. In this case, you cannot, default is strict. And then we updated the leaderboard script so that it would count the amount of type ignores for each team and the amount of any's for each team. We chose not to fight around MyPy bugs, but we chose, hey, find workarounds, write a code in a different way, add an assertion, even add a cast if needed, maybe with a runtime check, but add a cast, so don't try always understanding why MyPy doesn't work. Sometimes MyPy is complaining about things it shouldn't. That's it. Maybe you can check another day when a new MyPy version is released. Oops, sorry. When there is a deserialization or annotation issue, do a runtime check, so put a guard for the type if the type is not what we expect. This is kind of feasible for deserialization, okay, but there is another gotcha that we need to be absolutely clear about is mind your untyped external libraries. This is another source of bugs. So today you have an external library. The library returns a string, but the library has no type annotation. So you work with that library, just say, hey, that's a string. I can just annotate, type a string, or cast. The return type is string, and that's it. It works. That's right. That's right today. But tomorrow, your library is still untyped. You will update your library. The type can change by mistake or because the author wanted to change the type, and you won't notice in your code. So whenever you have an untyped library, which is external, you should be mindful of validating any kind of type it brings into your code base, or you will get a kind of bad surprise at the worst moment during the night with a production incident. Okay. As I said, I suppose that many of you have an idea of how to solve the problem for this realization, and the answer is Pydantic or strict or whatever. There are multiple libraries now that can properly bring the right types in your code and fail if the type is not right. But for this, one more recommendation is mind your types. So you have an untyped code base, you don't annotate, you get there and you ask MyPy what kind of type is that variable. Okay, MyPy will tell you that this is your type. Okay? This is not uncommon. So please get your types right before using Pydantic, because otherwise you can enter another set of bugs where type coercion by Pydantic can again lead to unexpected results. So if I remember correctly, Pydantic picks the first type that can work for a variable. So maybe you have a string with an integer, okay? And it will use a string, even though the type could be an integer, it will make more sense. So personally, I think that unions are almost always a risky choice for data structures when you want to serialize or deserialize them. I prefer choosing a better type, but that's just my opinion. Somebody just loves unions, and that's it. We're getting to the end of this talk. So the big question is, Would you, and would my company do it again? Definitely yes. Okay, so the value that we have extracted in the end, now that our code base is almost completely typed, is very high. We have a better developer experience. We can do large changes on many parts of the code base without them being disruptive or risky. But there is another question that we are asking to ourselves. Not the right question for a conference like EuroPython, I understand, but the answer to this question is maybe. But for sure, we would reconsider the language choice earlier in our development path to see, hey, is the tool we are using still the right one for the kind of size of software that we are heading into? And if you've seen some talks today, even talk by Antonio about SPy, okay, it seems that every time we want to do something better with Python, everybody tries to come up with a more restricted version of Python, not with a more powerful version of Python to do everything. And adding types is part of it. But yeah, maybe Python is very nice, but we should be aware of its shortcomings. That's it. Here you can find the slides to the script and my pages. Thank you.
Thank you, Alan, for the awesome talk. We now invite questions from the audience. There's a microphone behind. You can make use of it to ask questions.
Got a couple of questions. Your point about like the whole if is instance and all that kind of thing, where you're really basically submitting to the type checker. I've had a bit of pushback with collaborators when doing that kind of thing. Do you think that kind of thing is worth it?
If you can talk a bit louder, because I don't think I have understood your...
Okay, sorry. I'm referring to the bit where you said like if is instance, so you're really like ensuring that the type is true. It was later on. It was much later on.
Okay, let me find. I understand the slide, but now I can't find it, of course. It was. This one.
Yeah, this kind of thing.
Yeah.
So like, if let's say you know the type is something, but MyPy disagrees with you. Mm-hmm. So you're really forcing by doing is instance, so therefore you're actually slowing down your code. Mm-hmm. Do you think that kind of thing is worth it just to get the typing?
So usually, yes, from the correctness point of view, yes. But usually, to do this right now, we just use Pydantic, okay? We don't do this manually. You can also use an assertion if you are absolutely sure that it's just a MyPy issue, because the assertion with O2 or O3 won't be run. But frankly speaking, at least in my context, where we need to be more reliable than fast, I absolutely want correctness first. Okay, so I prefer that because there is no way the wrong result gets out of here. You can have different trade-offs in your application. I cannot tell you about that.
Okay, thanks. And my other question was, have you used Astral's TY or the Meta's one, whatever that one's called? And have you noticed the speed change?
I swear, we didn't use Pyrite, we didn't use TY. I can tell you that switching a type checker once the full type checking is working is probably quite an effort, because type checkers can have slightly different behaviors. That's not what we want to do right now. We are thinking about it for one reason, because now we have separated our monolith. Well, we still have a monorepo, but we have multiple sub-projects. Once upon a time, when I started this talk, the full type checking of our code base took, on a fast machine, over 20 minutes. Okay, so we said, hey, we could have wrote everything in Rust, and the compiler would have been faster. Now it's better because we have individual sub-services, so type checking for each of those is faster. Maybe if TY existed 2 years ago, we would have tried. Now, today, we may still consider it, but I don't think it's so critical for our code base right now.
Okay, thanks.
Is it on? Thank you for a nice talk. My question is about, if I understand, there's two ways of doing type checking. One is inline, and then the other one is stubs or something similar, to have a separate file with all the definitions.
Yeah, of configuring the type checker, yeah.
No,
So you run the type, so MyPy is still not built in, it's a separate executable, and you can configure it launching MyPy with a config file, or you can do the or MyPy can read the configuration in each of your files.
Okay.
Okay. One of these options was not available at the beginning, actually. Now it is. But the latest version that we are using is to have a configuration not per file. So this is not per file, this is per line. So you only ignore the specific error in that line, even if the error changes. So that line is still a problem, but it's a different error. MyPy will tell you it's a mistake. So this way you cannot accidentally introduce. So the point is that the path to get your code base typed is strictly, you can only improve your code base if you don't add type ignores. It can get the same or better, but you cannot accidentally make it worse by adding something which is a different ignore that you would not have thought. That's the point.
Okay, thank you.
We still have some time for more questions. Okay. All right. A round of applause for Alan.
Thank you very much.